Okay, so we're going to do 2 application problems from Edgenuity. This is the first section of Unit 10. So these are from the assignment, and hopefully they'll help you out. Okay. As always, please, if you run into trouble, ask questions, and I will be more than happy to help. Okay, let's start. A satellite orbits in an elliptical path such that the Earth's center is one of the foci of the ellipse. So right from that sentence, we know something about a foci, and we know that we're dealing with an ellipse. Okay. Now, if you look at all of the answer choices, you will notice that they use a center of 0, 0, so we're going to do the same. Okay. The distance from the center of the orbit to the Earth center is 4,100 miles. So you know not the A and the B, but you know the C. Remember, C is the distance from the center to a foci. The foci are halfway between the center and the major axis vertice. Okay, so let's draw a picture of what you know. So if you know that this is the center and you know that this is the major axis vertice, you know that the foci is right in the middle. Okay, so if it's right in the middle and the center to the foci is 4,100 miles, and if it's right in the middle, then foci to the vertice is 4,100 miles as well. So now you know the A. 2 times 4,100 miles. Oops, put my comma in the wrong spot. Which is 8,200. So if I square that, I get a fairly large value. 67,240,000. Okay, so now what I can do is I can use the equation for the foci to find the b squared. Okay, if you remember, the equation for the foci of an ellipse is c squared a squared minus b squared. So we're going to do 4,100 squared. Oops. I already have my a squared. And we're going to use those to find my b squared. Okay, so I'm going to use my calculator. So 4,100 squared, and then I'm going to subtract the 67,240,000 from both sides. Okay, and that gives me negative negative 50,430,000. And that's a negative b. Well, the negatives will cancel. So now I have my b squared. So now you actually have a possible equation of your elliptical orbit. X squared over 67,240,000 plus y squared 50,430,000 equals 1. Okay, that wasn't too bad, but it's really important to read your problem and to understand what's going on. Okay, so let's do this next one. This one deals with a parabola. Okay, again, we're going to assume a vertex of 0, 0. Okay, all right, and if you look at your answer choices, they're all of the form y equals 1 over 4p x squared. Okay, so that makes it a little easier. We know what our parabola looks like. Okay, so I'm going to have to draw, whoops, that looks a little funny. little picture here. Okay, a mirror is shaped like a parabolic curve with a width of 3 inches and when it is a depth of 0.375 inches. Okay, so we have a width. Okay, now width is all the way across, right? So the total width would be 3. So on each side, it would be 1.5. Okay, now remember, left and right is an x value. So if your vertex at 0, 0, you have an x value at 1.5. Okay, now it says a depth of 0.375. So that means if you go up like that, the y value is 0.375. Okay, believe it or not, you have enough to find your equation now. You have an x value of 1.5. Okay, and then you have a y value of 0.375. So now we're going to use those values to find our p. Don't get your x's and y's confused because that's what I did when I first did this problem. 0.375, 1 over 4p, 1.5 squared. Okay, so I'm going to multiply both sides by 4p. Okay, now I'm going to multiply 0.375 times 4. And I get 1.5 p, 1.5 squared. Now I'm going to divide by 1.5. Okay, now if you remember your rules of exponents, this is actually pretty, you don't even have to find out what 1.5 squared is. You just use subtraction of the exponents. So your p is 1.5. So now, if we use our equation, so 4 times 1.5 is 6. So 1 over 6, x squared. And that would be the equation for our parabolic mirror. Okay, I hope this was helpful. Again, if you need help, please text or email me at any time.